do you graph a piecewise function? Here's an example of a piecewise function. Let me read it out loud to you. F of x is equal to x squared if x is less than or equal to 2, 8 minus 2x if x is between 2 and 4, and 4 if x is greater than or equal to 4. What you have to remember about this notation is that everything that's going on over here, those are the expressions for the function. That is the y equals. And what's going on over here, those are the restrictions on the domain. So this is what's going on in the domain, in the x values, and these are the y values. So let's see what we can do if we want to try and graph this piecewise function. So let me set up my axes here, my x-axis and my y-axis. And we're restricting our domain to everything to the left of 2, then everything between 2 and 4, and then everything to the right of 4. So let's mark off 2 and 4 on our x-axis. So first, everything to the left of 2. To the left of 2, we have the function y is equal to x squared. That's our basic parabola passing through the origin. And it goes up to the point where x is equal to 2. And when x is equal to 2, y squared is 4. So we have this piece of the parabola. This is a y value of 4. And because this over here says x is less than or equal to 2, we are including this endpoint, so we fill it in with a filled-in circle. The next piece is the part that goes between 2 and 4 on the x-axis, and that is y is equal to 8 minus 2x. 8 minus 2x you should recognize as an equation of a line. So we just need 2 points, and then we can connect the dots and make the line. So when x is equal to 2, plug a 2 in for the x. 8 minus 2 times 2, 8 minus 4, that's 4. Aha! We happen to be right at this same point right there. And when x is equal to 4, 8 minus 8 is 0. And I'm going to put an open circle here because the endpoints are not included in this part of the domain. We have a straight line segment connecting those 2 points. Now, because we have an open circle and a closed circle at the same point, we could just think of that as one filled-in point. And now the last part of our graph is y is equal to 4, and that's everywhere where x is greater than or equal to 4. So y equals 4 represents a horizontal line, starting with a filled-in circle at a height of 4. This continues forever in this direction, and this piece continues forever in this direction. And if you look at this graph now, it's continuous, meaning we can draw it without lifting our finger everywhere except for the point where x is equal to 4. So an interesting question might be, what is the limit? Let's make a new slide. Let me give you a quick redrawing of this graph. We had that parabola passing through the origin. We had that line segment. And then we have that horizontal line. Sorry, this is an open circle. This one's filled in, filled in. And I could ask you, what is the limit as x goes to 0 of f of x? You just look at the graph and you see what are the y values getting close to when x goes to 0, and that's going to 0. I could ask, what is the limit as x goes to 5? Remember where 5 is. 5 is right around there of f of x. And again, you look at the graph, what are the y values when you're near 5? And the y values are all equal to 4. The tricky part is at that point where there's a jump. The limit as x goes to 4 of f of x. Problem here is this limit does not exist. And the reason this limit does not exist is because the limit as x goes to 4 from the negative side, from the left side, is if we follow along here, that's equal to 0, while the limit as x goes to 4 from the positive side or the right side, we're following along on this piece, and we're at a height there of 4. If the left-hand limit is not equal to the right-hand limit, then the limit does not exist. The end.